Just wait for things to catch. Just wait for things to catch. I set timer. Right, I think everything's set. So let's get going. Righty-ho. Right, we're back. So tonight we're going to finish the Python module. So we're going to finish the Python first course, and then we'll be moving on to starting the Linux one. We were meant to do that yesterday, I realised, or like today, can't remember. But we didn't quite get there in time. But there's been a lot of stuff we got through. We got a lot of classes and a lot of optional things. So the next ones are going to be a little bit quicker, which is good because I hope to. That's going to be a bit of a beast to get through. Get through Go for a second time, and SQL and stuff like that. So yeah, it's going to be a bit of a beast, but we'll get through it. Anyway, let's finish off Python, then we'll get there. Hearts go out to everybody. All right, let's get started. So we're on the challenges, like last two sections, challenges and a quiz. So in this chapter, we're going to practice applying the skills and concepts we learned while building Fantasy Quest. Write a function called number sum n that takes and adds up all the numbers from 1 to n, for example. For example, this and this. Okay. So sum, we're just going to go straight into it. So sum of numbers is going to be 0, and then we're going to do a loop. So for I in a range of 0 to n, then we're going to sum of numbers plus equals n, and then we're just going to return sum of numbers from that. Oh, 2 failed. Adds up the sum of all numbers from 1 to n. Whoops. And that again. 1 passed, 1 failed. 1 to n. It's going to be n plus 1. Nope. inputs 3, expecting 6, actual 6. Inputs 5, expecting 15, actual 20. 1, 2, 6, 6, 10, 15. Oh. Let's just debug that one quickly. What have I done wrong? Oh, dummy me. It's just going to be I. No. There we go. Just offset it. So it starts at 1. Okay, minimum number in Python. So write a function called findMin that finds the smallest number in a list. So a little trick it was always telling us about was min so far equals, and I forgot the infinity thing. No, I forgot. Positive infinity. Oh yeah. Since you're trying to keep track of the smallest number, start with a really big number. Python's a built-in constant, so min is float infinity. I forgot that syntax. I don't remember that one. So I'm going to be for num in nums, and then we're going to compare. So if num is less than min, bless me, then min equals num. Return min. So it does. Bingos. Oh, I got that crack then. Complete the remove non-ints function. It takes a list and returns a new list with all the non-integer types removed. So remove non-ints. Yeah, remaining list after removing is that. You can check if a variable's type using the type function. Type equals int, so that's going to be pretty easy then. All non only ints equals an array. I'm going to do for loop for num in nums. If and then basically this block. So if type num equals int, then only ints dot append num, and then return only ints. Easy peasy. Factorial. Complete the factorial function. It should calculate the factorial of a number. A factorial is a factorial of a number is the product of all positive integers less than or equal to that number. For example, 4 exclamation mark equals 4 times 3 times 2 times 1 equals 24. Note in mathematics, the exclamation symbol denotes a factorial but is not used in Python. Tip: special case for 0. The value of 0 is 1. This keeps factorial consistent with the convention of for an empty product. Okay, so we're going to create a sum. What is it? No, it's result of factorial. It's going to be 0, and then we're going to do 4 I, whoops, in range so it's going to be num to 1, and we're going to go backwards at -1 a step. So then we're going to do result factorial sort of factorial you can do times equals I think that's going to be it, and then return result factorial. Nope, completely failed. Expecting inputs 1, expecting actually 0. So what's going on here? We're doing something wrong. So print this up a little bit. So nothing happened there. Is it stepping through correctly? 4, 3, 2, 1. Yeah. We're going to go to 0 with that one. Input 0, expecting 1. Okay. Five, 4, 3, 2, 1. Actual. So that's not the shorthand for multiplication, is it? So multiply. What was the function to times? Math. What's short? Python short and multiplication. Is there a multiplication assignment? Yeah, I thought it was that. Why is it not doing it? Result factorial. Oh, it's because it starts with 0. Me dummy. So doing something simply wrong. So it's going to be it's going to step through. It's going to be starting. This one passes, but this one's starting from so this has 4. Hold on, I wonder if the +1's throwing it off. There we go. Yeah, I thought it was. Cool. And submit. Bingo. area sum. So complete the area sum function, accept the list of rectangles where each rectangle is a dictionary that has the following structure. So height and width. The function will calculate the area of each rectangle and return the sum of them all in the result. Function will calculate the area of each rectangle, then sum them all as a result. I'll just run in and see what it's like expecting. Input's expected 56. So, okay. So, sum of rectangle. Sum of all areas equals 0. Then we're going to do for rectangle in rectangles, and then we're going to be area is going to be rectangle dot. Oh, I can't use that syntax, can we? Whoops, that's the wrong one. Height. Whoops. Times rectangle width, and then we're going to do sum of all areas plus equals area, and then we're going to return sum of all areas. All right, 1 second. 1 second. I've got something I need to sort out. Brief interlude there, not to worry. That passed, so I'm pretty confident it's going to pass all of them. Yay. A few more. FizzBuzz. Hey, FizzBuzz is a commonly overused little toy program that comes up in entry-level interviews. This is a little testable spin on it. Complete the FizzBuzz function that loops over all numbers from start to end, excluding the end value, and adds them to a list it returns. If the number is a multiple 3, instead of appending the number, append fizz. If the number is multiple 5, instead of appending buzz. If it is a multiple 3 and 5, then instead append FizzBuzz. For example, start 1, end at 8, then the resulting will follow contain. Okay, so we're going to create, we've got a start and an end. So we're going to need to make a, numbers array, which is going to be equal to that. And then what we're going to do is we're going to do for I in range. And I'm going to do start to end. And then we're going to basically just numbers array dot append I, and that'll basically give us like a numbers array from like this start to the end. So like if it's 1 and 8, it'll do 1, 2, 3, 4, 5, 6, 7, 8. And then what we're going to do is we're going to do FizzBuzz array equals numbers array. And then we're going to do for in a number in FizzBuzz array, and then we're going to do so if this is going to be like the noddy way of doing it. Whoops. if number modulo 5 equals 0 and number modulo 3 equals 0, then it's a viz_buzz. In fact, hold on. I'm not sure if this will work actually, but like viz_buzz array number equals, then we'll replace it with viz_buzz, and then after all that we're going to return viz_buzz array. No, it can't do that. I didn't think so. Whoops. We're just going to have to do that again. So if it's going to be like that, and then we're going to say current. I was just going to say number equals viz_buzz array, and then I, and then I'm not sure if this will work, but I'll try it. Yeah, the same. Doing wrong here. Viz_buzz array. Actually, I'm a bit of a dope. Just realized 0 to length of fizz buzz array. Whoops, I'm a dum-dum. So now it's just, now the loop works better. I'll just be total brain fart. So L if number modulo 5 equals 0, then number equals which way around was it? Like, so multiple 3 and 5, then it's multiple 5 buzz L if number modulo 3 equals 0, then number equals fizz. Let's print it out. I'm doing something wrong. So number, what the number is. So 1, 2, 3. Okay, so 1 and 1, 2 and 2. Why is that not doing that there? I think it's because of this, actually. It's in the wrong order. Nope, not quite. So, doesn't pass on that one. If the number is a multiple of 3, instead of appending the word fit, instead of appending the fit fizz, if the number is a multiple of 3, but I'm doing something really simple wrong. Fizz 3. If it's not divisible by that, else if it's not divisible by that, think it's just the assignment thing. It doesn't do that, does it? So yeah, let's have a look how they did the solution. It's probably a much more succinct way. Oh, they did it without doing the thing. Yeah, okay, that was much simpler. I overcomplicated that by far. Write a function called divide list. That takes a list and a number as an input. The function returns a new list that contains all the elements of the original list except they have been divided by the second input. Toasty in here. That's it. The function returns a new list that contains all the elements of the original list except they have been divided by the second input. So divided list 6, 8, 10. I would say print list. Make sure you're appending the raw footwise. Don't round down or cast the number to integers. Okay. So we're gonna call it new nums. That's that. We're gonna do for num in nums, and we're gonna do new nums dot append, and then we're gonna do num divided by 2, and we'll return new nums. Whoops, what am I doing there? Why did I put the... Anyway, don't know why I did that, I was silly. And we're almost there. So, join strings. Write a function called join strings that takes a list of strings and returns a single string. Concatenate the strings from the list end to end in order with a comma in between them. Don't use join string method. Okay, I'm going to call it joined string equals that, and then we're going to do for string in strings. We're going to do joined string plus equals a string. We're going to put in a thing. It's almost there, it's just got the thing at the end, so like we need to get rid of that extra one. How do I get rid of that extra one? You don't want a comment at the beginning or the end of the final string. We're 0 to length of strings. So if I is equal to length of strings, then we're going to do this, but like without the thing. Else we're going to, whoops, my JavaScript muscle memory is kicking in too much here. It's going to be join string like that. Oh yeah, whoops. What we're doing, so string equals strings I. Nope, still failed. Let's see what their solution was. I bet there's probably an easy one. Yes, they started the same. So for s in strings, joined. Oh, so they did the same as me, and then if length joined is not equal to 0, joined equals join minus 1. Alright, okay. I forgot about that. That's quite a nice little syntax. Boom, we made it. We made it. So we're on the last thing now, and then we'll be getting on to Linux, like we said. Plenty of time. So we've got how many things? We've got 8. The Zen of Python. Tim Peters, a long-time Pythonista, describes the guiding principle of Python in his famous short piece, The Zen of Python. Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. Flat is better than nested. Sparse is better than dense. Readability counts. Special characters aren't special enough to break the rules. Although practicality beats purity, errors should never pass silently, unless explicitly silenced. In the face of ambiguity, refuse the temptation to guess. There should be one, and preferably only one, obvious way to do it. Although that way may not be obvious at first unless you're Dutch. Now is better than never, although never is often better than right now. If the implementation is hard to explain, it's a bad idea. If the implementation is easy to explain, it may be a good idea. Namespaces are a one honking grey idea. Let's do more of those. So is better than, simple is better than complex. It's okay for special cases to break the rules. An implementation that's easy to explain is a good idea. Maybe. There should be obvious ways to accomplish a task. 1. Which language typically allows code to be released the quickest? Oh, hold on. So why Python? Here are some of the reasons we think Python is a future-proof choice for developers. Easy to read and write. Python reads like plain English. Due to its simple syntax, it's a great choice for implementing advanced concepts like AI. This is arguably Python's best feature. Popular. According to Stack Overflow's survey, Python 3 is the third most popular coding language in 2024. Free. Python, like many languages nowadays, is developed under an open source license. It's free to install, use, and distribute. Portable. Python written for one platform will work on any other platform. Interpreted. Code that can be executed as soon as it's written because it doesn't need to take a long time to compile like Java, C++, or Rust. Releasing code to production is typically faster. Why not Python? Python would be the best choice for a project if code needs to run fast. Python code executes very slowly, which is why performance-critical applications like PC games aren't written in Python. The code base will become large and complex due to its dynamic type system. Python code can be harder to keep clean of bugs. The application needs to be distributed directly to non-technical users. They would have to install Python in order to run code, which would be a huge inconvenience. Which language typically allows code to release the quickest? Python, I guess. The best reason to use Python is because it rows run fast. Slow code. Python 2 versus Python 3. Okay, one thing that's important to keep in mind as you continue your Python journey is that Python ecosystem is fragmented. Python 3 released on December 3rd, 2008, but over a decade later, the web is still full of Python 2 dependencies, scripts, and tutorials. In this course, we use Python 3 just like any good citizen would these days. One of the most obvious breaking changes between Python 2 and 3 is the syntax for printing text to console. Python 2, Python 3. Update the code from Python 2 to Python 3 syntax. Much nicer. Python 2 needs to die already. Yeah, probably. Should you use Python 2 or 3? As you probably guessed, you should probably always use Python 3 going forward. Python 2 and 3 are similar. Python 3 contains significant changes that are not backwards compatible with 2x versions. Python 3 code is always backwards compatible with 2. No. Breaking changes are never. Okay. And you completed the Learn to Code in Python course. Hey, course completed. You finished the Learn to Code in Python course. 10% of students have completed this course. Wow, not many. So if I claim that, hey, and whoops, where did that go? Oh, I'm going to save this. Download. Let's put that on my photos. Get that in there. Bingo. Nice. Let's share this on X. Just ignore the that crazy post that's down there behind. Ooh, this is nice. Sorry if you guys aren't that interested in this, but I'm going to be posting it, so. Bingo, that's nice. Very nice. Okay. Done that, I've done that, I've done that. Nice. Okay, leave some feedback. Saves 530, nothing better. Awesome. Friendly course. Oh, I get a thing. Nice. Continue. Oh, I got more rewards. Hey, I didn't. Are these just all the things I haven't unlocked thus far? I've just kind of just sat on them. I'm gonna open them. Let's see what they do. Oh, come on. Don't be shy. Don't struggle too much. I don't think this site. Oh goodness me! I think my microphone's like way off. Yay! There we go. Get some more. Open some more chests. I'm gonna have to have a look at my microphone. It's a bit crazy. No, it's all right. Looks okay. Come on. Open the chests. What's going on? Oh goodness me, he's not having a good time here. Let's just refresh the page. He's really struggling. It's not my internet, is it? No, there's something up with Boot.dev. Let me just close it. Boot.dev. Boot.dev, you okay, bro? Damn, it's struggling. Definitely something up with Boot.dev right now. This is not me. Whew, here we go. What was all that stuff? So I open this. I got loads of rewards to unlock. So I got the acolyte. I got the sharpshooter reward. Spray. Yay! I don't use any of these, but yay! It's fun to get them. Yay! Oh, come on! You can do it. You can do it, Boot.dev. Boot.dev, you okay? Am I getting rate limited? Am I getting rate limited for opening too many chests all at once? Come on, I can't be too... Oh, I think I'm definitely getting rate limited or something. is not happy about that. Hold on. Alright, got this. Got any more? Hey. Streak lost. Oh yeah, I remember that. I think I get the rest. Yeah, I've got some golden things. I don't really know how to use it. Stuff. I'm not too bothered. Not too fussed. Yeah, we finished it. We finished it all. It's done. Go back to courses now. It is time for Linux. We will get started. Enter the course. Please, please, please. Here we go. This is what you guys have been waiting for. We've got 10 hours of content. And we've got just like another hour or so of this stream. This is the fourth stream doing this. It's Thursday, isn't it? Yeah. So 66 addicting lessons. Earn a certificate of completion. Learn online at your pace. So we are going to start the course. Never fear a Linux terminal again. Learn how to use the command line, navigate a Unix file system, and automate developer tasks. Bingo, 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 bingo. Right. So there's not many chapters. This one's only 6 chapters. We'll see. We'll just see. We go through it. We learn. No need to rush these things. I just want to get them all done in the air. So welcome to Learn Linux. Welcome to Learn Linux. Admittedly, the course name is a bit of a misnomer. It's called Learn Linux because Linux is just what most students think of regarding the concept of this course. A more accurate title would be Learn to use shells and terminals in a Unix-like environment. That's a mouthful. Learning goals. Understand the difference between a shell and a terminal. Learn how to navigate and use the file system using the command line. Learn how to install software using the command line. Understand how to manage your path and environment variables. Learn how to manage permissions and execute programs. This course will get you comfortable working on a command line, which is a skill that's going to be critical for the rest of your career as a programmer. So instead of writing code in the browser, in this course you'll interact with the command line interface directly on your machine. Our machine, okay. Find and open a terminal on your computer. See below for instructions. Type the following command and press enter. So 3 when you're done, answer the question. How to open the terminal on Mac? Well, we're on a Mac, we're on Windows today. How to open terminal Windows? Open command prompt application. You can find it for command prompt start line. So it's internal. I don't want the instructions for thing. I want a terminal one. So is it power prompt? I think command prompt lets you switch to what you call it? Yeah, I want a command prompt. Ubuntu one. So it's going to connect to WSL, I think. Is it? Yeah. So we're going to use this. We ain't going to use no Windows rubbish. In fact, only Windows share. So we got this, and we're going to jump back and forth between this one and this one. So we're going to have so echo hello world. What happened when you pressed enter? The hello world printed to the terminal's console. Bing. Command line versus GUI. In other Boot.dev courses, you may have ran your code by clicking a run button, but as a real developer, you likely run your code using command line interface instead. For example, in Python, you would run a Python code file like this: Python main py. What's the CLI? You'll often hear terms like terminal, shell, command line, CLI, and command prompt used interchangeably, but often they all refer to the same thing. A program allows you to interact with your computer in a text-based way. Whoops. What is a GUI? Just listen to this one briefly. Yep.
The words terminal, shell, command line, CLI, and command prompt are often just thrown around haphazardly by programmers. And even though the precise definitions vary slightly, we're usually talking about a program that lets you interact with your machine through text. If you're new to the command line, you're already probably familiar with GUIs, or graphical user interfaces. And a GUI is just a fancy visual interface that lets you get stuff done on your computer. Think of a Windows desktop, for example. It has menus to sift through, icons to click on, and even complex window management systems. A CLI, or command line interface, is a much simpler alternative. Instead of using complex visual buttons and menus, you interact solely through text. Want to run a program? Don't click on an icon, just type the name of the program. Want to view a file? Don't open Microsoft Word, just type a command. Now, while GUIs do have a lower barrier to entry, that is, they're often self-explanatory to use, they're also pretty limited. A command line interface is more powerful because you're not limited to the buttons and widgets that are provided by application developers. Instead, you get direct access to the lower levels of your system. As a programmer, it's non-negotiable. You need to be comfortable on a command line.
That's fair enough. I'd probably disagree with all that. Although we'll see how AI sort of changes our interactions with computers in the future, but that is something else to behold. So to be fair, it's usually easier to teach people to use a GUI than a CLI. You can simply point to the things and say click here or drag there. But GUIs do have some drawbacks. They're weak, they're slow, they're not as reproducible, they're not automatable, they're not as cool. So in your terminal, run the following command. Who am I? Oh, what happened when you ran the command? The text a dum-dum was printed. Terminal crashed. My username was printed to the console. I got an email. Installing Windows subsystem for Linux. You can stick this deck if you're on Mac OS or if you already have WSTool configured. I know this course is called Linux, but if you're on Mac, it's Unix-like enough for the lesson in this course. Built in Windows, a command prompt is terrible in my opinion. It's so bad that if you're on Windows, you're just going to have to install WSL2 Windows Subsystem for Linux. So allow you to keep using your normal Windows desktop, but also have a Linux command line operating system file system for your programming work. Thank you for being a great, not you, command line environment. That's funny. WSL was a huge step forward for developers on Windows. You get a Linux operating system and command line experience without the need to dual boot. WSL is a official Microsoft product. It won't mess up your base Windows install. You'll still be able to run Steam. Here are a couple of things to keep in mind about WSL2. There are two versions of WSL2 and we'll be using the latest version 2. The WSL2 file system is completely separate from your Windows file system. Use normal Windows like normally for games, documents, Windows apps, wherever. I recommend using Linux file system for your code. So I've done that. Windows Update. Click on Start menu, Windows Update. Done that. I already have it installed, but I'm just checking I'm not missing anything, missed it before. Open the Windows command prompt and install WSL2. Click on the Start menu and begin typing command.exe. You should see command prompt. Right click and run as administrator, WSL install. I've already done that. Restart your computer, confirm WSL installed, WSL-L-V. Set up the Ubuntu distro. Ubuntu is a very popular distro. After restarting your computer, start you should see Ubuntu window automatically once you log back. If you don't, search Ubuntu program. Just check that. Yeah, it's there. Blah blah. Once you're logged in, you see type that. Boom. I'm done with this step. Yay! So, what is a terminal? As we talked about, the term shell, CLI, and terminal are often used to refer to the same thing, a program for issuing text-based commands. But to get pedantic, the terminal is just one specific part of that program. Historically, the word terminal meant a physical device that you could type commands into, essentially a keyboard and a screen. These days we say terminal, we really mean terminal emulator. A terminal emulator is a program that emulates a physical terminal. It's a program that lets you type commands into a window on your computer. Which commands you're able to use is determined by your terminal emulator, but by the shell, it isn't determined by the terminal emulator but by the shell, which we'll talk about later. Your terminal emulator is just responsible for drawing text on screen and processing your keystrokes. A terminal emulator is a program that accepts your text-based commands and can render it onto the screen. What is a shell? So if your terminal is just a program that lets you issue text-based commands and renders the output of those commands, what is the program that runs those commands? That's the shell. Shells do a lot of things, but their main job is to interpret the commands you type and execute them. REPL. Shells are often referred to as REPLs. REPL stands for read, evaluate, print, and loop. This is a fancy way of saying that shells are programs that read the command you type, evaluate those commands usually by running other programs on your computer, print the output of those commands, give you a new prompt to type another command and repeat. Assignment. If your own shell, in your own shell, run the following command. Okay, so print that. 1, 3, let's copy it. Bingo. So that's just to, express these two numbers added together. Variables. If you're using Ubuntu WSL, you're probably running a bash shell. If you're using blah blah blah, if you're running full Linux, I pray you already know what you're doing. The point is that you're probably using bash or ZSH, and for the purposes of the course, they're actually basically the same. Both bash and ZSH are shells. And they also happen to be very powerful programming languages. They have variables, functions, loops, and more. That said, only crazy people write large programs in shell languages. Shells are optimized for running other programs and writing small scripts, not for writing large applications. Create a variable, so like that, name equals lane. Use a variable, so echo that. Unlike Python, where you can just use a variable's name, in your shell you need to prefix the variable name with a $, to use it. Assignment. For the rest of this course, you'll be using a forensic developer hired by the fictional World Bank to investigate a security breach. Like most mega corporations, they don't know what they're doing, but they're happy to overpay you to come in so that they can say a third-party expert has reviewed their systems. Turns out you're not an expert. You're happy to learn on someone else's dime. So why not jump onto the opportunity, right? Anyhow, you'll be using your terminal and shell to traverse files, manipulate text, run programs, and investigate suspicious activity. Set the following 3 variables in your shell. So like this. And then we're going to write and execute a command that will print the following using echo and the dynamic variables you just set. Paste the entire command that generated the correct output in the text book, be able to submit it. Okay. So World Bank, so bank name, founded, CEO, was founded, so echo, bank name was founded by CEO. Yay! History. When you're working with REPL, it's really helpful to be able to see the commands you've typed in the past. That way you can easily rerun them or copy and paste them into a script. To print out the history of commands you've typed in your shell, use the word history. So history. Bingo. I've used a whole bunch of stuff as well. Probably not supposed to see. In your shell, set two variables: department to engineering, team to ops. Use echo to print the following message using department team variable names. So I work in department. Var. Wait, hold on. What was the text again? Oh yeah. So department equals engineering. Team equals ops. And then we're going to echo that. So we're going to echo I work in department on team. Run history command and paste the output into the text fields like that. Navigate history. You'll often want to rerun a command. You just type it out again, but assuming you don't have WPM of the primary. What's that? Words for a minute. You'll often want to rerun a command. You can just type it out again, but assuming you don't have the WPM of the primogen, that's a pain. Arrow keys. You can use the up and down arrow keys to quickly cycle through your command history. Focus your terminal window and use the up arrow key to start cycling your history. If you recently restarted your shell, then first type a few commands like echo like this. Once you've cycled back through your history, up arrow and use down arrow to cycle back to the most recent command. If your terminal is feeling cluttered with text, you can clear it with clear command or by pressing Control L. It won't delete your history, it'll just clear the screen. Just like that. The up arrow goes back in your history and the down arrow goes forward, up and down. Bingo. Navigate history. Yeah, it's the same thing. The clear command opens new terminal, clears terminal screen. Terminal alternative. How do you clear terminal clear history? Reset or put reset. So reset. Guess that works. History. Nope, that doesn't work. So history clear. Okay, awesome. Terminal alternatives. So far, we've been likely working at the default terminal that came with your operating system, and that's fine. However, there are other options, and I want to highlight a couple of them, just in case you want to check them out, but you don't have to. Editor ID built-in terminals. Most text editors for developers have a built-in terminal. For example, VS Code, Z, and Cursor popular text editors also have a built-in terminal. While I do use Z's terminal for most of my coding work, in this course, I do not recommend using built-in terminal because we don't need the extra text editor features. Ghosty. Ghosty is a very new terminal emulator that differentiates itself by fast, feature-rich, and native. It's a great option if you love to customize and want modern, fast, rich terminal. Alacrity is another popular terminal emulator that is known for its speed and extensibility. Before Ghosty, Alacrity was the go-to terminal for many developers who wanted a fast, customizable terminal. Well, I can't speak. Windows terminal is Microsoft's substitute for Linux terminal. It uses command.exe program settings to change the default terminal, but be sure to start WSL whenever you open the new window. Is Ghosty for Windows? Ready to run binaries for macOS and built for it? Nah, we don't have that. I need to get a Linux machine. Which is not a terminal emulator. You want to do? Oh, nice. So we finished chapter 1. Bingo wingo. And we got 45 minutes, so we got a decent amount of time. See how much we can get through. Some like really long modules in this, I imagine. If we get through 2, maybe 3, 4, we'll set ourselves in good stead for like finishing it off next week. Maybe only one night to finish it off, we'll see. What is a file system? So all the data stored on your computer is organized into files and directories. Files and directories are organized into a tree structure called a file system. Directories or folders on Windows are just containers that hold files and other directories. Files are just a dump of raw binary data, ones and zeros. So, the bytes in a file can represent anything, text, images, videos, etc. The file system tree starts with a single directory called the root directory. The root directory contains files and directories, which can contain more files and directories, and so on. When you open your terminal, your working directory, the one you're in, is going to be somewhere. Most commonly, it is your home directory. Assignment. You've remotely logged in onto a suspicious employee's machine at World Bank. First, you need to determine where on their file system you are. Run the print working directory command to see the file path of the current working directory. Paste full output of the terminal into the command to submit it. So, Boot. Yeah, that's private. Yay! File paths. Oh, I just turned my thing off as well. The output of Boot is a file path. A file path is a string that describes the location of a file or directory on your computer. Yours should look something like this. Yours should look something like this. Users, blah, blah, blah. The wags lane. The text might be different, but the structure should be the same. Let's break it down. The first slash represents the root directory. It's the tippity top of the file system tree. The next part, users, is the name of the directory inside the root directory. Finally, the last part, wags lane, is the name of the directory inside the user directory. So this path represents a directory 2 levels down from the root directory. Blah, 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 blah. And let's play this briefly.
With the command line, file paths are the bread and butter of navigation. You're probably already used to thinking of files and directories as nested tree structures. After all, that is what they are, and that's how Windows Explorer or Finder on Mac display them. A file path is just a text-based representation of one file or directory in the hierarchy. All absolute file paths start at the root of the file system, which is just the very top directory in the hierarchy. From there, everything is nested inside a tree of directories, with each directory in the file path separated by a slash. Now, if the path you're looking at points to a file, then the last section of the file path will just be the name of the file. But if you're looking at a path to a directory, then the last section will be the name of the directory. To give an example, in this hierarchy, the path to homework.txt is /documents/school/homework.txt. And the path to the work directory is just /documents/work.
Okay, so assignment, start digging into time to start digging for evidence. If you're on Windows, again, make sure you're using WSL2 terminal. Copy and paste the code to download the World Bank directory from GitHub. It contains files and directories you need to, throughout this course. If prompted for a password, use your password. If your machine's user, will cover what these commands do later. If you run into an issue, see the troubleshooting and get tips. So let's think of that, and let's whoops, hold on. So cd hold on. How do I get So we're going to do unzip. I'm cheating because I already know some of this stuff, so I'm just going to make a directory for boot.dev. I'm going to move world bank into boot.dev. ls slash so cd boot.dev ls slash cd world bank slash okay, so we're in there now. I'll read these last two commands again so that it's definitely thingied. Okay, yep, cd word bank. We'll cover these commands later. If you're entering through blah 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 blah, you should now have a world bank directory in your current working directory. When learning terminal commands in this course, it's possible to make a mistake and ruin your version of the world bank repo. If that happens, just come back to this lesson and download the world bank again. Run the ls command to see the current directory, current working directory. So ls. You should see world bank list selected. Run a change directory command to move into the world bank directory. So see here, use ls command again to see the contents of the world bank directory. Paste the console output into the text field and submit your answer. Submit. Yay! Certain Windows versions may not let you paste into the command line, blah, 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 blah. Yeah, we're okay with that, so it all worked. How are we doing for time? Yeah, we've still got 5 minutes. We get through this. CD command. The CD command changes directories to move into a directory, but how do you move back out of the current directory? The answer is 2 dots. It's a special 2 dots is a special alias that refers to the parent directory. It's a shortcut you can use to move up one level in the directory tree. Navigate out of the world bank directory, so you're in its parent directory. If you're on the top level of the world bank, just type cd ... Then run ls command again, but pass the name world bank directory and submit the thing and stuff. So cd ... ls world bank, and then paste the thing into here. Yay! Absolute versus relative paths. We've mostly been dealing with relative file paths, which are paths that take your current directory into account. For example, let's say we have the following directory structure in our file system. When inside the top level vehicles directory, the relative path to the mustang.txt file is that. However, when we're inside the cars directory, the relative path of the mustang.txt file is just that. Or when we're inside the Forge directory, it's just that. Absolute paths. An absolute path is a path that starts with the root of the file system. On Unix-like systems, Mac OS and Linux, the root is denoted by /. So if the vehicles directory is the system root, the absolute path for mustang.txt is this. So when we're inside the Forge directory, you can either use that or that. Don't show that again. To refer to the same, which should I use? It depends. Relative paths are easy to read as long as you're in the correct directory or the directory you expect. They're easier to reason about. Absolute paths are more explicit. They're useful, but when you're not sure what directory you're currently in. For example, maybe you're giving someone instructions how to find a file on their computer. You can't be sure what directory they'll be in. When they start following instructions, you'll need to use absolute path, which is a relative path. This one. Home run, Ryan. Absolute versus relative path. So another question. Which path will refer to the same file regardless of the current working directory? That one. Absolute path. You're probably familiar with the concept of files using the GUI like Windows Explorer or Finder. At their core, files are just blobs of data. The raw bytes in a file can represent anything: text, images, videos. The cat command. Command is used to view the contents of the file. It's short for concatenate, which is a fancy way of saying put things together. It can feel like a confusing name if you're using cat command to view a single file, but it makes more sense when you're using it to view multiple files at once. Print the contents of a file to the terminal. So cat file 1. Concatenate the contents of multiple files and print them to the terminal. Assignment: use cd command to navigate to World Bank directory if you're not there already. Use the ls to confirm that you're in the right place. You should see public directory listed, cd's public directory. You should see a file called prideas.txt. Use cat on that, print the thing. So cd World Bank public, and then cat Yay! I've not read all that, but I've not got time to go through all that. It's probably just some funny stuff. Head and tail. Sometimes you don't want to print everything in file. Files can be really big after all. The head command. The head command prints the first n lines of the file where n is the number you specify. So head n -n 10 file 1 txt. If you don't specify a number, it will default to 10. Tail command. Tail command prints last n lines of a file where n is the number you specify. Assignment: time to start investigating the bank's transactions. So cd command to get into the World Bank private transactions directory. Ooh. So private transactions. Run cat command to view the contents of 2023 CSV file. You'll notice it's a really long file. We don't want to print the whole thing. Use the head command to print the first 6 lines of 2023 CSV and copy them to the input field. Do not submit yet. So head and 6 and what was it, 2023? Yes, very nice. Do not hit submit. We print the first lines, first 6 lines, because the first line in the file is the header. I want to include that along with the first 5 transactions. Use tail command to print the last 5 of the 2023 and copy them into input. Same again. I'm just going to do 5. It's going to be tail, like that. Yay! More and less commands let you view the contents of the file one page or line at a time. As the adage goes, less is more. In the context of these commands, less is literally more. The less command does everything that the more command does, but also has more features. As a general rule, you should use less instead of more. You would only use more if you're on a system that doesn't have less installed. Assignment: you found nothing suspicious in the first and last transactions of 2023, but you're not done yet. It's time to dig through the middle of the file as well. So run less and pass in the path 2023 CSV file located in the root, blah 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 blah. So run this. Ooh. You can use the spacebar to scroll down a page at a time. You can go back up by pressing B. Find line 153. Copy and paste the contents of that line into the file. Submit it. You can use how do I know line 153? Oh, hold on. print out the line number. Big dummy. Oh, I like that. I'm going to use that at some point. Yay! Less. Use less. Very nice. The touch command updates the access and modification timestamps of a file. By default, if the specified file does not exist, touch will create an empty file with the given file name. Because of this side effect, you'll often see this command used to quickly create new empty files. By default, if specified file does not exist, touch will create an empty file, blah, blah, blah. So touch a new file. You can also create multiple files at once using by listing them. Touch can be very handy when writing scripts because it ensures files exist without altering existing ones, creating new files only if necessary. Assignment: you discover a discrepancy with the credit card files. World Bank is supposed to keep editing credit history records, but they aren't. Change into the World Bank public products credit cards. So CD dash CD one up, and where are we? World Bank public. So public products credit cards. Create a new file named credithistory.txt so they can keep track of the information. Use ls to verify that the file has been created successfully. So touch this ls like that. Paste the contents of the credit cards directory into the thing you submitted. Yay! Directories. As we mentioned before, a directory is just a location in a file system that contains files and other directories. On some systems, directories are called folders, but it's the same thing. The mkdir command, the make directory command creates a new directory inside your current directory. Mkdir my directory. Assignment. During your digging, you find a file that appears to be out of place. Make sure you're in the World Credit Cards one. Yeah, that's where I am. Run ls from there. You should see a file named tbills.txt. Treasury bills. T-bills are a type of investment, not a credit card. Go back to the products directory and create a new directory called investments. List the contents of the products directory again and confirm the new directory is complete. Okay, so and then mkdir, and what was it called? Investments ls. Yay! Okay, move. The move command moves a file or directory from one location to another. You can use it to rename a file or to move it to a different directory altogether. Your working directory can't be the directory you're moving. Renaming a file, so some file to some other name. Moving a file from the current directory into another nested directory, so the file here into some directory and then a file. Moving a file from the current directory into the parent directory, so this file into upwards, that one. If you don't want to rename the file and you're just moving it to a different directory, you can omit the file name. Assignment, so move tx bills from World Bank public tx bills into the new public blah 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 blah. Keep the file name the same. List the contents of the investments directory and paste the output into the field of your answer. So we're going to move where was it again? It was credit cards. What was it called? T bills, and we're in products, and then we're going to put in investments. ls investments. It's in there. Bada bing. Remove. The remove command deletes deletes a file or an empty directory. Remove some file.txt. You can optionally add rflag to tell the rm command to delete a directory and all its contents recursively. Recursively is just a fancy way of saying do it again on all the subdirectories and their contents. So assignment: change directories to World Bank private. So So hold on. World Bank, World Bank pass, and then we're going to go to the private one, see private, and then we want to use cat on command to view the contents of World Bank private passwords, password.txt. What we find in there? Oh my goodness, everyone's passwords. Hold on, what do they say about Gandalf? Oh, Gandalf the Grey. Foo Fighters is in there. The password on my luggage. Bookcase, password. Correct horse battery staple. Higgledy, Piggledy, I guess. But yeah, there's a big problem here. It looks like someone is storing passwords in plain text, even on a private machine. This is a big security risk. Delete both the passwords directory and the passwords.txt file. Then it lists the contents of the private directory again to make sure the file is gone. rm it's going to be passwords, push, and then ls and privates. Oh, just the ls. Like that. Bing, bing, bong, bing. Easy squeezy. The copy command does what you would hopefully expect. It copies a file from one location to another. So cp source file to the destination. You can also copy a directory and all of its contents recursively by adding the r flag. So my directory to the new directory. Assignment. Take a look inside the World Bank private transactions directory. You should see a few lines contain transactions from different years. So ls, where is it? Transactions. Okay. Look inside backups directory. Inside there, looks like something's missing. What's missing? 2020. Let's copy the missing file from transactions directory to the backups directory. So there's a full backup of all this. Okay, so cp transactions 2020 to transactions backups, and then ls transactions backups. Bingo, we moved one over. Yay! Easy McSqueezy. Home. In a Unix-like operating system, a user's home directory is the directory where their personal files are stored. It's also the directory that a user starts when logging into the system. I recommend doing all your development work in your home directory. For example, I like to create a workspace directory in my home directory, and all my programming projects live in subdirectories there. Danger, your home directory is where you want to spend most of your time. Many of the other directories on your machines are critical to the operating system or other programs. Be careful when working in other directories like bin, etc. and var. You can mess up your system if you're not careful. The alias. So my home directory on Mac is located. It uses wags lane. The tilde character is an alias for your home directory. So when you want to go home, you don't have to type cd uses wag lane. You can just type cd like that. And it takes me all the way back. And then go back, because I know that's a secret one I'm not telling everyone. What does file path or workspace name CSV refer to? Workspace in the name CSV directory in the home directory. The name CSV file in a workspace directory in the root directory. Name CSV file in the workspace directory in the home directory. That one. grep. You might be used to nice graphical interfaces that allow you to search for text in files, usually with Control F or Command F. But what about when you're working on a terminal? As it turns out, once you're used to it, searching for text in files on a CLI can be much faster than a GUI. The grep command. The grep command allows you to search for text in files. It has a ton of capability and will only be scratching the surface of its true power. Basic usage. The most basic use of grep is to search for a string in a file. For example, if we want to search for the word hello in the words text.txt, we could run grep hello words.txt. This will print out every line in words.txt that contains the word hello. It's case sensitive search, so it will only match hello, not hello or hello. Assignment. Applications often write their logs to files on disk. These logs can contain useful information about what the application is doing and can also be used to debug problems. As a security auditor, you need to dig through these logs to find any evidence of suspicious activity. Use grep command to find any lines with the text critical, all caps, in the World Bank private logs 2024-01 log file. Paste the output of your grep. So cd ... and I want to do grep. You have to put quotes around it. Yeah, you do. Grep like that. In where is it? In private logs 2024 or 110.log. What have people been doing? Boots is loose in the server room. Server is on fire. Please evacuate. Someone the root directory database files are corrupt. Funny. They really put effort into this course. You can tell they really put effort into this course. It's got a lot of funny content, and it's just well done. Congrats. Well done to Boot.dev. It's really good. Grep multiple files. You can also search multiple files at once. For example, we wanted to search for hello in hello text and hello text 2. We could run like that. Recursive search. You can also search the entire directory using all subdirectories. For example, to search for the word hello in the current directory and all subdirectories, do that. The dot is a special alias for the current directory. Assignment. Use grep command to find all the lines that text critical, all caps, in World Bank private logs directory. So it's going to be the same again. Whoops. Sure. Boots is out salmon again. Yay! I like using this. This is the sort of stuff I never learned along the way. Some basic things that kind of developers take for granted. But I kind of skipped over all this. I was like, I just learn as I go. Nice to come back and do a whole bunch of fundamentals. Find command is a powerful tool for finding files and directories by name, not by their contents. Well, let's say you're looking for a file named hello.txt. Or somewhere in your home directory, you can use the find command to search for exactly that title. So find some directory -name hello.txt. The pattern search. So the find command can also so you're looking for a file named hello somewhere in your home directory. You can use find command to use a search for exact title. Find some directory, name that. Pattern search. Find command can also search for text files that match a pattern. For example, if you want to find all files that end in .txt, you could run find some directory, name, and then .txt like that. The asterisk character is a wildcard that matches anything. If you're trying to find file names that contain a specific word, you can use the asterisk character to match the rest of the file name. Find all file names that contain the word Chad. Directory like that. Assignment. You've been tipped off that fraudulent activity seems to happen often with the joint accounts. Joint means accounts that have more than one owner. Use the find command to search the World Bank public products directory for all files that contain the word joint in their name. Paste the output in things. So public products. So find public products. And then joint. Oops. There we go. Users. Unix-like systems like this one use and support multiple users. Each user has their own home directory, their own files. Oh, we're on something else. So we're on permissions. How long we got left? Yeah, we'll do a little bit of this. I don't know if we get through it all. Maybe we'll get through it all. It's like, what, 9? We get through 9, and then next week we're doing like 3 more chapters in one night, and then that'll be it. That'll be on to the... We'll be doing the next course by that point. So we've done Linux, and then we'll be doing Git. Git. And then we're doing a project. Woo, can't wait for that. Unix-like systems like the one you're using support multiple users. But yeah, we'll stop at permission tonight if we do that. Got 16 minutes. We'll see if we can get through it. Might be a nice way to finish it off. So, hold on. Each user has their own home directory, their own files, and their own permissions. If you're like most people these days, you're the only user on your machine, it used to be more common for multiple people to share a single computer, or for multiple people to do their work on the same computer over a network. The sudo keyword lets you run a command as a super user. It's short for super user do. To use it, you'll need a password with super user privileges, which you should already have if you're the only one on your machine. Some people are pedantic, pronouncing sudo as sudo. Sudo. Others are correct and pronounce it sudo. Yeah. Sudo grants unrestricted access and can risk system damage if you don't know what you're doing. All commands in this course are safe, but other commands should be reviewed before running sudo. So the assignment: run who am I command to see who they're logged in as. Run the same command as root. You'll be prompted for your password. Enter it, copy and paste the output of the command into the inbox and submit your answers. So sudo who am I. So yeah. I'm root. Yay! A Unix-like operating system permissions control. Who can do what with to which files and directories. The permissions of an individual file or directory are visually represented as a 10-character string. dr wx rw xr wx. Break it down. I remember this like Boolean stuff. It's like read, write, execute and stuff.
In a Unix-based operating system like macOS or Linux, all files and directories have a set of permissions associated with them. Now, there are 2 ways that we break down those permissions. The first is who has the permission. The second is what permission do they have. Now, in regard to the what, any user accessing a file or a directory may or may not have access to read it, write to it, or execute it. Now, all of those permissions, both the who and the what, are represented by a 10-character string. The first character is always either a D or a dash. If it's a D, all that means is this is a directory. If it's a dash, it just means this is a file. The next 3 characters, RWX, represent the 3 permissions that we talked about: read, write, and execute. And the who that they apply to is the owner of the file or directory. The owner is usually just the user that created it, but it can be changed manually. Now, this RWX section can have several different states. Each permission can either be granted, in which case the letter is present, or it can be a dash, in which case the permission is not granted. So, for example, RWX means that the owner can read, write, and execute, while R-X means that they can only read and execute, but not write. And R-, means that they can only read. Finally, this set of RWX permissions is just repeated twice more. The next set applies to the group instead of the owner, and the last set applies to everyone else. So to break down a full 10-character string, let's take
Do that
In
again.
a Unix-based operating system like macOS or Linux, all files and directories have a set of permissions associated with them. Now, there are two ways that we break down those permissions. The first is who has the permission. The second is what permission do they have. Now, in regard to the what, any user accessing a file or a directory may or may not have access to read it, write to it, or execute it. Now, all of those permissions, both the who and the what, are represented by a 10-character string. The first character is always either a D or a dash. If it's a D, all that means is this is a directory. If it's a dash, it just means this is a file. The next three characters, RWX, represent the three permissions that we talked about: read, write, and execute. And the who that they apply to is the owner of the file or directory. The owner is usually just the user that created it, but it can be changed manually. Now, this RWX section can have several different states. Each permission can either be granted, in which case the letter is present, or it can be a dash, in which case the permission is not granted. So, for example, RWX means that the owner can read, write, and execute, while R-X means that they can only read and execute, but not write. And R-, means that they can only read. Finally, this set of RWX permissions is just repeated twice more. The next set applies to the group instead of the owner, and the last set applies to everyone else. So to break down a full 10-character string, let's take the example of D RWX R-X R-. The D means that this is a directory. The RWX means that the owner can read, write, and execute. The R-X means the group can read and execute. And the R-, just means that everyone else can only read this directory.
Nice. Put really simply, really easily. So he's been through all that. So the first three layers are the owner permissions. The owner can usually create the file directory. The next three are the group permissions. Unix like system support groups of users. And the last three characters are the other permissions to everyone else. My experience when you're doing programming work on your local machine, you mostly just care about the owner permissions because that's usually you. Here are some full examples. So a file where everyone can do everything. A file where everyone can read and execute, but only the owner can write. A directory where everyone can read ls the contents and execute cd into it, but only the owner can write, modify the indexes. A directory where only the owner can read, write, and execute. Which permissions allow everyone to read? So everybody else is that one. Which permissions allow the owner to execute? That one. Changing permissions. The chmod command lets you change the permissions of the file directory. It's short for change mode. I wish this was called change permissions, but alas. Assignment. As part of your security audit, you need to know who has access to the files of the private directory. The ls command has an L, -L option, lowercase l, that will print out the permissions of each file in the directory in long format. List the files in the World Bank private directory along with the permission using ls-l. So, whoops, where am I going? ls-l private. Change the permissions of the private directory and all its contents that the owner can read, write, and execute. The group can do nothing, and others can do nothing. -r user can read, write, and execute. The group can do nothing, and everyone else, others, group, and owner. You, just mean the user, really, doesn't it? Like so, like that, and it's going to be private. In the commands above, U means user, aka owner. G means group, and O means others. The equals means set the permissions to the following, and RWX means read, write, execute. The G equals and O equals means set group and other permissions to nothing. The -r means recursively, which means do this for all the contents of the directories as well. But be sure to replace directory with a private directory member. Dot is a special alias for the current directory. Once you've changed permissions, run ls-l. Make sure they've been updated. Paste the 10 character permission string for the updated private directory into the input of the field and submit the answer. Whoops. Who am I? Why is that changed it? Private directory. Oh, right. Okay, that's the problem. It's not really a tip. That should just be something you know. So I'm just going to ping you along with it. So this, I don't know what it's going to be. It's going to be read, right, dash, 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 dash. It's going to be that. Executables. You're familiar with the idea of reading and writing data into files, but what about executing them? Executable files are just files where the data stored inside is a program and you can run on your computer. Files with .sh extension are called shell scripts. 1, 2, 3, 4, 5. Yeah, okay. They're just text files that contain shell commands. You can run a file in your shell by typing mkdir program.sh. Interestingly, if the program is in the current directory, you need to prefix it with a // to run it. As far as file paths go, program ./program.sh and program.sh are the same. The dot is an alias for the current directory. We need the prefix when running executables so that the shell knows we're trying to run a file from a file path, not an install command like ls mkdir chmod. Assignment. There seems to be a suspicious script in the World Bank private bin directory called genids.sh. It looks like it generates some type of identifier. First, let's remove our ability to run it just to see what happens. The chmod command has a community-x flag that will simply remove the execute permission from the file. So run the following commands in World Bank private bin. So cd private bin, and then we're going to do that. Okay, and then let's get those permission. Let's test those permission and try to run the script. It's not thinking it for me because like I'm on the WSL, so it's just a error like this. The error occurs because the executable permission is not set in user, the owner. Let's re-add them by doing much than that. yeah, so chmod x plus x, so it like dash x. That'll simply remove the executable permission from the file, and then push x will give it execution back. Paste the output of the scripts. So yeah, we had to kind of like thingy that one a little bit, but never mind. Just the way it is on Windows. Get the Linux set up at some point. The root user is a super user. It has access to everything on the system and can do anything. When you use the sudo command, you're running as the root user as long as your system hasn't been configured differently. The sudo keyword is convenient because it quickly gives you elevated permissions to run a single program. Make me a sandwich. What? Make it yourself. Sudo make me a sandwich. Okay. Okay. Hi Emmanuel, you alright? From Nigeria. What time is it there? Is it it's early? Oh no, it's like late at night there, isn't it now? Like, hope you're doing well. However, it can also be dangerous because it gives you access to everything. If you run a command with sudo that you don't understand, you could do some serious damage to your system. For example, rm with the R and F flags on the root directory will delete all the files in your system. Don't do that. The R flag is for recursive, delete everything inside, and F flag is for force. Most systems will prevent you from doing this, but if you run it with sudo, you've just turned your computer into a very expensive paperweight. So modern systems will actually prevent you from deleting everything by default as a safeguard unless you use -- no preserve root. But it's still a very bad idea. Should I use sudo? Sure, as long as you understand that command you're doing, just be careful. Which is a super user? Root. Hey, oh, whoops, no, should have been Chuck Norris. Chuck Norris is a super user for definite. What happens if you do sudo rm-rf? Your computer will be wiped clean of all files, including files need to function. Your computer will be wiped clean of all files but still function normally. You lose your collection of dank memes. Everything else will be fine somewhere in the world. Linus Torvalds chuckles. The first one. So when do you need to use sudo? Chmod allows you to change the permissions of any file or directory that you own, but what if you don't own the file or directory? That's where sudo is required. Let's change ownership of a directory to see how that works. The chown command stands for change owner, allows you to change the owner of a file directory and requires root privileges. Change a directory to World Bank private. So let's go one. Oops. // you should see a directory called contacts. Take a look at its contents. Emergency. You should see a file called emergency txt. Take a look at that using the cat. What was it called? Contacts. Emergency. Not much in there. Let's see something. Seems like there's some personal contact information for employees. We don't know whose this is, but we're pretty sure it should have access strictly limited. Let's change the owner of this entire contacts directory to root. So sudo chown root contacts. Like that. Turns out. Here's an explanation of the command. So sudo run as the root user. Chown, command to change the owner. Recursive means also apply all the changes to everything inside the directory. And root, the name of the new owner. Contacts the directory to change the owner of. The name of the owner. 5 from World Bank private directory run ls. Paste only the line from the output that represents the contacts directory. It's going to be sudo oh no, we're supposed to change it to root. Whoops. Root root. I ran the command, it would have run fine. It's just Windows being a numpty, it's fine. Using sudo, before you start using this assignment, make sure the permissions on World Bank private contacts directory are this, and the owner is root, and that you're not signed in as root. If you've been following along, all those should be true. You can check with the last command. You told senior staff about contacts directory and its contents, and they've decided to delete it entirely. Go ahead and try to delete the contacts directory with the RM like that. RM contacts. The contacts directory should fail to delete. You do not have permission to delete. It's owned by root user and you're not root. Try again as root sudo. Once you've confirmed that you were able to delete it, run ls command from inside the private directory. Yay! Let's just ignore the permissions problem with WSL2. Programs. We're going into compile versus interpreted. Compile versus interpreted. But we are going to leave it there for tonight. We have made good progress. And we will stop there. Tis good. All things are good. All things are good indeed. We can close that. And then just put it back to just me. Cracking. Well, that was a really eventful night. We got through plenty. I hope you enjoyed following along so far. Got the first certification today and posted up on LinkedIn. Woo! We're getting through things. I hopefully get to some stuff that's like more advanced like later and stuff, but I'm enjoying going through from basics again and doing the fundamentals because I haven't done Linux and stuff like this like for a while, and I just picked up as I go, so I'm bound to have missed things along the way. So that'll be it for tonight. I'll be back next week, Wednesday and Thursday, same time, same place, and we'll be doing the rest of by the looks of it, we'll be doing the rest of Linux and moving on to the next. So we'll probably have to list it as the next one's going to be Learn Git Part 3. So as long as nothing happens on second night, we'll be doing that. I'll only probably just schedule one ahead. But anyway, if you're coming from the future, thanks for coming back. If you've been here, sitting here live, really appreciate it. It's been lots of fun. We're getting through things and I'm getting more confident on camera and everything as well, and I'm learning as we go. Hopefully you all are too. Good night. I'll be the same, and see you in the next one.